Oh, holy shit, it actually works. Alright, let's see what's up today. Hopefully the stream is going to be stable. I'm streaming from my hotel room, so let's hope it works. Okay, hacker news. Let's see what we got here today. Hold up, let me zoom in on this because it's a little bit out of focus. Can I zoom in? Oh, yeah, I'll do it here. Okay. How to request removal of your contact info, relevant test scores. Huh. Slow news day, I guess. The hotel I booked online became a homeless shelter and no one told me. Multi-kernel drifting. Why isn't Dart more popular? Huh. Honestly, I'm not really sure which one to focus on today. Monte Carlo. Play Doom 1 and 2 in the browser. That seems kind of cool, actually. Measure and bill software as a service to customers based on your usage. How to maintain engineering velocity as you scale. Okay, this looks actually pretty interesting. Okay, and then Microsoft earnings Q1, fiscal year 23. Oh, this should be interesting. Let's see what people said. Growth is only in cloud revenue. Yeah, lower than expectations. Cloud's a big reason. Amazon reports in 2 days, taking a hit. Yeah, that's pretty much it. Yeah. Quarter revenue was up 31% constant currency. So basically, last year it was up 31%. Now it's only up 24%. So people's expectation of growth kind of just ate shit. So let that put it nicely. Huh. Cloud services bringing more money in than productivity and business suites. Yeah, that's been true for a while actually. So you're kind of late to the train, buddy. Alphabet earnings. Huh. Let's see what they got going. Alphabet third quarter results. Pleased to announce revenue is up 6% last year, or 11% on current currency basis. Yeah. I think people were really expecting 30% year over year actually, there's no freaking way you could ever get that. So, okay. So you get you do get 30% net income growth, which is about right. Other expenses, operating margins are like insane actually. Google's always been like that. So let's see, search. Okay, search decline, YouTube ads increase, Google network advertising. Okay, advertising dropped. Traffic acquisition costs. Okay, this is the acquisition costs. Okay, so costs went down. Oh, oh snap! If you look at this, they actually admit that they laid off 20% of they lost 20% of their employees. Whoa. Maybe a touch above 20% really, but operating results, operating income. Okay, so Google services and other bets. Okay, other bets are starting to pay off a little bit. Google Cloud, still operates at a loss, but services operates still at a gain. So, yeah, I'm not too impressed with cloud as far as operations, but I'd have to actually see the the actual numbers. Okay, but let's see the balance sheets. Okay, not much burn. Yeah, so they actually they decreased property, plants, and equipment, which means that they probably decrease the amount of capex they spend. So they're building up their reserves. That's what all the missing parts of the balance sheet actually end up in current assets. Liabilities, okay, decrease in liabilities, about the same actually. So the equity stays about the same. They mostly short up the balance sheet, which is fine. Revenue, net income. Yeah, they're decreasing their cost of revenue, which is fine. I think that corresponds to the down of revenue as well. So that's fine. G&A gets so they're becoming more efficient. I think that's the tail they're trying to spin here for the net income. Even though it grows, I think they're still trying to spin this as a more efficient Google, which I kind of understand. Okay, cash operating by free cash flow. Sure, 16 billion in free cash flow. Why not? Revenues remain constant. What? Yeah. I'm more interested in these segment results actually. So quarter ending in 2021, 59 to 61. Google services grew. They grew cloud services, but by this much. Okay, so they grew cloud services by 2 billion, but then bottom line, but the operating income only goes up by 50. Wow, that's a 4% segment. Holy crap. They're really spending a lot on this Google Cloud actually. If you have only 4% operating margins, that's really weird. Or incremental 4% operating margins. That doesn't seem quite right. So I don't know. I'm not I think it's in line with what we saw for Microsoft's cloud where growth is slowing. But I'm really surprised the incremental margins is actually this bad. So I'm not sure where what the capex is on Google Cloud, but I imagine it's very high. So that's kind of interesting. Huh. Okay then. Hmm. 0 to 10 million lines of Kotlin code. Oh, engineering at Facebook. Very nice. We're sharing lessons learned from our Android development. Kotlin's popular. Okay. Meta's Android repository is very large and reaches across our family of apps. Why not? Converting our code base to Kotlin. Yeah, which is the latest. We also compared Kotlin version with Java. Sure. Nullability. Yes, this is the big one. I think I've called this out many times in my stream before. The nullability, the built-in language nullability checks is awesome. Because you would use some other linters or detect tools to detect this in the past, and that often has some headaches there too. Kotlin support for inline functions and Lambda expressions. Yep, sure. So you don't need to have, let's see, it comes at the cost of anonymous objects. Yeah. So this is true in ArcsJava as well, where if you want to have like this functional programming style, you generate a lot of objects underneath the hood. So that actually consumes your memory quite a bit. Oh, hey Justin, what's up? Dude. Yeah, how you doing, dude? Let's see, shorter code. Kotlin's modern design makes code shorter. Yes, it does. Because it's implicit types. But you're relying very heavily on the performance of the IDE to tell you what the types are. Domain-specific language. Kotlin's various features come together and define a domain-specific language. Okay, whatever. You can write XMLs in Kotlin code. That's fine. That's all good. But I think adopting another language means we'll have to deal with source sets. Quirks do pop up at times. Yes, Kotlin does run into some issues when at scale, actually. Kotlin's a popular language, but there's a popularity gap. Why not? Yes, but there is interoperability, but you still run into mostly performance and technical issues, actually. So let's see how they approach the migration. With J2K, Java to Kotlin convert that comes inside Android Studio. Yeah, there's a bunch of edge cases. Yeah, so the conversion for the code itself, if you just run the tool inside Android Studio, is not 100% clean. Yeah, that's completely true. Feeling ready to learn. Yeah, yeah. I can understand where you're coming from. Let me know if you want me to talk about if you're okay with like. Here, you know, I'll message you on Discord. What's with the room change? Oh yeah, so I'm actually in Phoenix right now. I'm streaming from my hotel room actually, and so I'm in Phoenix because I'm actually helping to manage some infrastructure for Uber. So this is like a work trip. Okay. Yeah, yeah, yeah. So, yeah, I understand what you're feeling because of like, you know, you got the Google results back and basically you passed, but they had no more spots for you. So, it's really unfortunate. You passed the interview. That's the good one. We had one shot and it worked out, but holy shit. Like there's just no spots left. So that's really unfortunate. It's really annoying. Leave most of our existing code base in Java, convert almost all our code in-house. The advantage of the first option is that it's much less work, but okay, interoperability, static analysis, null checks, yeah. You basically interoperability and some really weird quirks with like how Kotlin reads Java JVM bytecode. Convert almost all our code to Kotlin, sure. Today, wow. They had to update Redux to support byte operations, yeah. So one of the things that you need to think about when you're converting to languages is that the bytecode output might actually be completely different than what you expect. I mean, yes, Kotlin says, oh yeah, our JVM bytecode, what we produce, is going to be read by Java, but what exactly does that mean? Like how much code is actually being produced, and is it going to be garbage or not? Is it easy to manipulate in these post-compile byte manipulation tasks like Redux? So they built Kotlin formatter, a deterministic Kotlin formatter based on the code and philosophy of Google Java format. Yeah, so they had to basically update all their supporting tools as well. Yeah. With our tools, convert any part of our code to Java. Okay, code, look at it. But do Kotlin. Run this at test will return a fail. Ah, yeah. So they're diving into a very specific example. Trying to run this test will fail and return an error. The rule expected common must be public since JUnit would be a private type field annotated with @rule. This is a common problem that has been answered many times in forums and be fixed either one of two ways. Add JVM field or use the annotation type to get rule. Okay, yeah. So you run into a few really weird issues where you need to be able to fix some annotations. I think that's basically the takeaway for this. I think this is a really fascinating blog, and I think anyone who is interested in these types of migrations should really read these. Because when you keep in mind, when you migrate language, you also need to migrate the supporting tools for it too. We post-process new Kotlin files. When they observe the commit, does it compile? For Java refactors, we use the Java abstract syntax tree to resolve types. Yeah, makes sense. Resolve limited automatic refactor. Okay, so you basically are doing a bunch of they're declaring that okay, we're gonna migrate all our files, do automatic refactoring once we've migrated all our tools. That makes sense. Reduce code length. Yep, there's definitely that there. Execution speed. Since Kotlin compiles the same JVM bytecode, we don't expect any execution speed regressions. A/B test, yes. Build size is not an issue. Wow. Wait. Hold up. Kotlin standard library is pretty small. Therefore, size has improved to be a situation where we add a few kilobytes of code. Okay. So they're saying that Kotlin code, when you compile the actual output of the Java JVM bytecode, actually is not that big a difference. But there's longer build times. Yeah. Because interoperability, yeah. So your build times kind of do die. Source only ABI in the Buck system. Okay. So they use Buck, which I've mentioned many times on other changes, like their in-house version of Bazel, which is meant to compile things on a module level and to be able to skip some compilations. So source only ABI, yeah. I think we may have done that. Annotation processing, yep, capped. Capped is generating Java code stubs for existing Java code annotations. It's nice to let your existing code work without modifications, but slow due to generation of a Java stub. The solution used KSP, yes, but I think they actually run into some issues with KSP actually. It does minimize the cost of running annotation process, but only if no capped-based processors remaining. Okay. Yeah. So KSP is Kotlin's new way of handling annotation processes, but you just need to get rid of the old one. Okay, that's cool. Hold up, guys. I'm gonna just get a hoodie. Wait, I can't. Holy shit. Okay, well, guess I can't mess around with the thermostat. Alright. Alright, let's bring on my client and see what's up. I can't mess around with the thermostat. Hey, hello?
Hello? Hello?
Oh, wait, I can't hear you. Give me a second. What the heck's going on? Hmm. Wait, why can't I hear anything? What the hell?
Hello?
What the heck?
Hello?
Yeah, sorry, I can't hear you right now. I'm trying to fix my shit.
Okay.
Huh. I actually can't hear anything from Zoom. Give me a sec. Let me restart.
Okay. Hello?
Oh, hello?
Hello?
Yeah, I can hear you. Can you hear me?
Yeah, can't hear you good.
Cool. Perfect. Yeah, sorry about that.
Yeah, no problem.
Yeah, how you doing, dude?
Dude, doing good. Doing good.
Yeah.
The rest definitely helped. I did I did revise my DSA checklist to add tests when you have your idea.
Mm-hmm.
So I've been doing that, but I noticed it's a bit slow. So I don't know if I'm overdoing it or is it because something that I kind of glanced over
Mm-hmm.
when I was doing these problems. So yeah, I've been I've been testing the ideas that you said, like if you have an array, do the empty, do it with one element, do it with two, etc. as your
Mm-hmm.
grow your example, right? So yeah.
Yes.
Um,
Mm-hmm.
so yeah. So today, well, yesterday it was going great, but then today I tried an interval problem, which which was kind of confusing because I didn't understand it off the bat. My problem there was like it's talking about grabbing all the disjoint set intervals, right? And in the example, they have they have like a closed they have a closed endpoint and then they have an open endpoint. But I was thinking back to my math classes because how are you gonna join that interval if one is 4.9, for example, and the other interval is 5, right? So that was my confusion there. So I kind of felt bad that I didn't do that problem right, or I didn't get to the brute force at least. So yeah. So I don't know if this one is one of those problems that are too focused on the math area there.
I don't think so. I think this is a pure logic problem. So what you just described is a like a disjoint set, right? And so all you need to do is if it overlaps or not. If it doesn't overlap and is disjoint, then technically you would never, the union of it would just, the intersection of it would just yield a null set. So I'm not really, maybe I'm not quite understanding the question, but yeah,
okay.
But it sounds like you're kind of reaching that stage where it's like, hey, am I doing too much? Am I not doing enough? So the first thing when I get to that question, the first thing is, am I at least solving the problem like over 80% of the time? Let's start there. Are you?
This problem in particular, or are you talking about
across all your problems that you've been doing with your checklist? Like let's take the last 30 problems that you did. Are you solving at least 80% of them and getting the answer and getting an answer?
Yeah, I would say so. Yeah.
Okay. And are you getting things? Are you at least getting an optimal answer as well for those?
For that, I wouldn't say it's as high as I would want it to be, but yeah, it's getting there.
Ballpark the number for me.
Let's see. Shit, for the last 30, yeah, let's say 60%, for example, right? Yeah.
Okay, yeah, so the thing is that you want to get that number up to like basically close to 80 as possible. That's our magic threshold because there's some problems you just can't do shit about, right? But any lower than that, you start, it's going to be on you, right?
Yeah.
And so you're thinking, okay, well, I would argue that maybe you're not thinking about enough things. It just depends on what problems that you've been doing.
Okay.
But one trick that you can use is that whenever you're trying to test your code, make sure every line of code is actually ran between all in your tests. So let's say you have like 10 tests or like 5 tests or whatever. What is the minimum number of tests to test every line of code that you have written?
Yeah.
So
like,
sorry, go ahead.
This is for like 100% code coverage, right? Or close to 100, right?
Yeah, it's one trick. I think it's a fake metric in my book because it's like, oh yeah, do I really need to cover like X some cases? But I think it's a good rule of thumb. Like eventually, once you get to these rule of thumbs, you will deviate away from them based on what you think is efficient. But I think it's a good starting point, especially since I know you tend to miss a lot of those like cases and stuff. So yeah, let me actually look at your practice diary. Maybe it'll make a little bit more sense to me as to what your problem is. Do you have the updated version of your checklist, and you've pinpointed what you feel like might not be good to have in it?
So let me let me paste it on the Zoom chat.
Okay.
And as far as one, Wait, and as far as one not, sorry, go ahead.
I was gonna say, like, are you in your? You can paste it in your practice diary, right? Or the prep doc.
Yeah. Let me do that.
Okay. Oh yeah. No, that's fine. It's fine. The DSA checklist, I have it now. Okay. 10 to 15. Okay. Okay. This is compressed. Yeah.
So with between 2 and 3, that should be condensed into 1.
Yeah, because this is like right here. This is repeated, right?
Yeah.
Yeah, so you could kind of just like you could just say 2 and 3, and then just like have this code, or whatever you have here, be like it's the exact same thing, right? Did I cover all the branches of my logic? The initial design, then when I write the code, do the exact same thing. And yeah, that's
so
go ahead.
So my question is like, let's say you want to write out the naive solution, and it's not that apparent to go to the optimal, right? So for that, would I have to do like the pseudocode and the testing, right? Because you at least want the brute force solution, right? So that's when I would say like just refer back to these steps, right?
Kind of, yeah. I would say that if you're in a situation where it's like, oh shit, I don't even know what the optimal solution or the road there, get something out on paper, and just say, hey, I want to get a naive solution out. Let me just make sure I do it. And the thing is that when you do the naive solution, it only comes down to like a very handful number of amount of code, right? So in theory, you should be able to come up with a naive solution very quickly.
Yeah.
But it's like, try every possible combination and permutation in an array is just 2 loops. That just saying that alone should automatically trigger you to write those. Like when you say an idea, the way I see it, whenever I come up with an idea, is that it's usually just chunks of smaller ideas, like Legos, put together, right? And I know how to make each one of those individual Legos like really quickly. That's basically what your naive solution is. It's just cobble a bunch of Lego pieces together that you already know how to make.
Okay.
And so because of that, now after that, then comes the hard part of like optimizing it. But based on what you just said, I think the strategy should not really change. But eventually, you will get fast enough that you can be a little bit faster, more efficient, and cut a few corners. But at this point, you don't really need to.
Okay.
So, yeah. So let me take a look at your practice diary, see what's going on here, because this looks very sparse. I don't see a situation. I'm not really sure I understand when you said that there's some things that you might want to take out. What things are you thinking about taking out? Hello? Oh, he dropped. Hold up, guys. Hang on, let's try to get him back, guys. If anyone has any questions of what we're looking at, feel free to throw it in the chat. But basically, what we're basically just looking at his checklist of how to approach problems, what he needs to do in order to get there. So like whenever you do a problem, there's like certain things you need to do and ask yourself, right? So.
Hey man, I accidentally closed Zoom. Sorry about that.
All good, all good. Yeah. So what I was asking is, hey, what makes you think that you need to start omitting things or you're not efficient enough? Let's start there.
In the problem log or in the checklist?
In general, because it seems like you're referring to the checklist of all the things you need to think about.
Let's see.
So I'm kind of confused. Like, where's this thought coming from?
As far as omitting ideas, I think what I meant by that is just to refine the practice, the checklist more as I do more of these problems. Because a few weeks ago it was like 2 pages, so I think as I do more of these problems, they'll eventually get smaller.
Mm-hmm.
Yeah, like from there, I guess I'll have more intuition on the testing, right?
Mm-hmm.
Because right now, like what I would do is like I would write, okay, test the empty list, test the list with 1 element, test the element with 2 elements, etc.
Mm-hmm. Yeah, no. You're gonna, like you said, you're gonna recognize when you need to test stuff, when you don't need to test stuff, and that's the intuition kicking in, right? I only give you a complete checklist to say, hey, in the worst case scenario, you better make sure you cover your ass, and this checklist covers your ass, right? When the chips are down, you don't fucking know what to do. This is what you pull out. But when it's like, oh, everything's good, I have a very good instinct of what's going on. I know what I need to do. I know, when you know what you need to know, it's going to be all instinct. You don't need to be as, as anal about following the checklist. Because it's like, oh, yeah, I can test this stupid little example and do that whole exercise out for the interviewer. But I'm going to skip that because I know it's right just looking at it. You get that instinct. Of course, sometimes your instincts are wrong. And you'll know when your instincts are wrong when you look back at the problem and just say, oh, shit, I didn't even get anywhere near the actual answer. And that's when you start going through the checklist, right? But for now, as engineers, we mostly rely on like our intuitions a lot of the times when it comes to these things because engineering, art is a science. But I think you can get sufficiently better than the average just simply by having a proper checklist. Anyway.
Okay.
So let's look at some of your problems actually.
So a quick question before we go on.
Yeah.
Like say we're doing a tree that involves binary search, right? That one, by then you have to be written it a bunch of times, right? So for that, would you say it'd be instinct just to write it? Well, would you go ahead and test it anyways, right? Um,
For tree problem.
like a binary search.
Yeah.
It's like this binary search tree, right?
hmm So yeah, this one would be like, oh, it's very stupid for me to like, because the search for binary search is like, oh yeah, if condition go left, if not, if otherwise go right or return XYZ, right? I've written that skeleton code like a lot of times, so I know for sure that's gonna be right. The only thing left to check would be to assemble cases that could check every single branch of my logic, and maybe chain some of them together, right? Because especially if there's like states that I'm carrying through each branch. Like for instance, like I might have to pass in a variable or something from the results from the last pass, right? Or last run, if it's a recursive solution. And so therefore I might want to also do a permutation of these different values for that passed in variable, right? So that's going to be a very obvious one to me. But outside of that, it's going to be like very simple, straightforward examples. I'll do one for every single branch of logic, and then I'll do one that kind of combines, and I'll do like a few that combine logic. Or I'll make one super example that combines every chain of logic I can. So in other words, it can boil down to anywhere between, I don't know, let's say 3 to 6 examples. But the first 3 are going to be very, very easy to do. So that's where your instinct kicks in. It's like, oh, this is so fucking easy because I've written this before. But yeah. So let me actually look at your practice diary. I think I made you write. I think in your checklist prep doc, I made you write out something, right? I think I made you write out.
It's like, how do you make sure?
Oh, why your test is complete. Yeah. So I'm gonna make sure that you did that in your homework. Are you hiding something that you want to tell me right now before I dig into it?
Hold on, let me see. I probably left it out in the problem log. 1 second. Yeah, so this is the kth element. 1 second. Also looking for this one. Where is it? Where is this from? Let's see. 1 second. Okay. Okay, so I did it for the array intersection.
Okay. I'll look at some of your problems while you're looking at that. Let's see. What state should I start with? 1025. Let me see. What row here? 13.
I would say
169.
Yeah.
Okay, 168.
Yeah.
9. Okay.
169. Yeah.
Compute the intersection of 2 sorted arrays. All right, binary search. With the assumption. Let me actually. Oh goddamn! I don't have fucking Elements of Programming interview on this computer. Hold up. Let me see if I can just download it somewhere.
Okay, yeah. So for the previous problem, for that one, I overwrote my test, and I did write it in my entry not to do that, because as I was testing the empty array, then I added the other, I added the test case for 1 element and 2 elements, etc. So as I was overwriting there, I was erasing my test cases.
Okay. But did you at least write a sentence? Did you write a blurb about like why your thing is correct? Why you cover your ass?
Let me see. So, yeah. So for that problem, I was stuck on it. I didn't get to complete it.
Okay, you didn't complete
So I was kind of stuck in the idea phase.
Okay. Yeah. So you're stuck in the idea phase. Let's actually look at that one then. Do
you have the?
Oh, okay. Actually, can you send me a link to it so I can download it from my side? Actually, hold up. Maybe I can find the book. Let me see.
I have the actual physical.
Okay, let me actually just see if I can get a copy of the problem online or some shit. Let's see. How's the program interview? Hang on.
Yeah, if you can't get it, I can send you a picture of this.
Yeah, if you could send me a picture of it, that'd be good.
Yeah, let me send it over.
Okay, let me see if I just in the meantime, let me see if I can just pull up a copy of the problem online or some shit. Okay, compute the intersection of two arrays. Looks like it's a LeetCode problem, so let's see. Okay, oh, it's an easy. What the hell? Okay, given two integer arrays, number ones and two, return an array of their intersection. Each element must be unique. You may return result in any order. All right. So you have an array with this one, and you have an output. Okay. Got it. So any numbers that are in one array, in both the arrays, you want to add it to the, what's it called?
The output array, yeah.
Yeah, okay. Let's see. With the assumption that one list will be larger than the other by a landslide. Okay, so you're assuming that there's an imbalance between the lists. Interesting.
Correct. So in the book, what they did was they did one solution where the two lists would be about the same.
Okay.
And then there's another problem where the solution is one list is much larger than the other one.
Interesting.
So what I did first was I looked at what would happen if they were about the same. Mm-hmm. And then I thought, okay, what if we're looking at a list of 1 million items? What are we gonna do?
Okay, I see. I'm gonna tell you right now, this thinking like that is not the first thing I would have done. I would have still gone for the whole naive, what's the simplest way of solving this problem, and then tried to solve the problem, and then got into the nuances after that. Mm-hmm. Yeah, that's this part of building up the problem. I think you took on that assumption, but I think it vastly overcomplicates your problem. I think just coming with a good naive solution up first, and then trying to optimize it for a scale is the right way to go. So I don't agree with this approach, but okay. Because the very simple naive solution is like for every single number or element in one array, you just check to see if it's in the other array. Convert it to hash maps and whatever. So I'm kind of interested in what exactly. So you're saying that you can get to a binary search. Let's see. Iterate over a smaller list while skipping duplicates. Don't you need to sort the list though?
If you're doing binary it's already sorted.
Okay. Okay, so you're taking advantage of the fact that it's sorted. Interesting.
Okay, yeah. So I forgot to mention that ELI 5 here is for like the more optimal way. In the problem log, I did state the naive solution, which is to run through one array and then look at the second one and iterate all that array. So you're iterating one array and then you're checking if it exists in the other array.
Yeah, you're doing binary search. Yeah, you're doing binary search in the second array, right?
Oh no! This is for the very naive solution.
Okay. Okay, so the very naive solution is for one array, you iterate through it, and then you check for every single element if it exists in the other array via binary search. Perfect. Okay, so that's a naive solution that works. But you're saying that there might be a more optimal way of doing this.
Or no, sorry. I don't do a binary search when I'm looking through the array. I just iterate through all the elements.
Okay. That's fine. But I think it's very obvious that if you're searching and you have a sorted array, binary search should immediately punch you in the face, right? So yep. It's okay to acknowledge that. Oh yeah, you can just iterate through the array, but I think it's very obvious to a lot of people that you can just go straight for the binary search approach.
Okay.
So that's your but you said that's a naive solution. What is the optimal solution then? I'm curious.
of, let me see what I did here. The optimal solution. Yeah, so here it says, okay, start at the end and moving over elements that are larger, right?
Wait, starting at
Using
the end and what?
um, hold on. This is for shit. Sorry, I was in the wrong problem.
That's fine.
Yeah, so this is where the ALI 5 says it's like with the assumption that one list is larger than the other by a landslide, iterate over the smaller list while skipping the duplicates. And then you do the binary search on the larger list.
Correct. Yes, that is a very easy way to do it. Because if you're suffering at m log n time or n log m time, you're gonna iterate through all the smaller elements, which makes sense. That's fine. I have no problem with that optimization. I think it's a tiny optimization, but it's worth mentioning. But I don't think it's worth oh yeah, there's not like some super complicated big giga brain one. So I think it's a very obvious one to call out.
Okay.
Is there anything faster than what you just described?
Yeah, there's the other one that I talked about in the prologue where you start at the beginning of the arrays, and then if the arrays are the same, you insert the values to the output array, right? Otherwise, what you do is you increment the lowest element. Okay. You increment it one time, right? And then you do the comparison again. Are these two elements equal? If they are, insert it to your output array. Otherwise, advance the element in the two arrays that it's much smaller.
Okay. I'm not quite sure I fully understand. So you're gonna, at each iteration, I'm actually reading the book. Let me see if I can fucking understand. It's not best when the array lengths are similar because exploiting the fact that sorry. We achieve linear runtime by simultaneously advancing through two input arrays in increasing order. Oh yeah, no. I see what you're going for. Yeah. Okay, so this is a two. They say the better way is to do a two-pointer approach, where if what you compare the values at each one is pointing at, and then you advance the smaller value, and just check to make sure that they're the same. If they're the same, count up, add it to the output array. So, I think that's the way I would have described it. Just it's a two-pointer, and when the elements are the same, add it to the output, otherwise to the answer. Otherwise, advance the smaller elements. So yeah, that's a very straightforward answer too. Okay. So in other words, the question now is like, why didn't you come up with that?
I did come up with it. That was actually my first optimal, and then I moved over to the binary search approach.
Okay. Good. So that's fine because it's fundamentally just the end of a merge sort, right? That's really what they just described. So now the question becomes, how do you want to test this?
Okay.
How would you? Yeah. Now that you know how the code looks and the idea is run, what is the test cases that you would run this against?
Okay. So let me see. Do you want me to say it off memory, or do you want me to look at what I did here?
Look at what you did, and yeah.
Okay.
I don't want you to do it off memory. I want you to do it based on what you see. And I don't have the link to your problem sheet actually here, so.
Okay. No.
Did you do it with pencil and paper or some shit?
No. It's here. Let me link it to. Okay, yeah. So for this one here, I'm looking. I actually tested the binary search. Like I did the empty list, and then with the target value, then I did a list with one element with target equaling that value, and then I did a two element array where the target is not inside the array, so that would return me false.
Okay, wait. You said you linked it to me. Let me actually see it.
Oh yeah, in the Zoom chat.
Cool. So I see the code. Okay, you put in the problem log. Okay, compute union, and then you have it in the two sort array. Wait, what page is it? The hell?
This is page. It's not telling me what is page is this.
Okay, merge two sort array. I found it.
13.
Okay,
Yeah,
cool.
14.
I got it. Update all entities, extra space. All right, whatever. Naive, Eli 5. Yeah, inefficient. Good call out. Optimal, good call out. Started to save the values. Okay, call it length array. Okay, so you call that out. Fine. Okay, you have your idea here. Perfect. Good. If array 1 decrement index 1. Oh, you went from right to left. Interesting. Not left to right.
Where's your cursor here?
Here, I'll highlight it for you. Do you see what I marked it yellow? Do you see it?
No.
I highlighted.
What page are you?
I am.
Oh, okay,
10.
okay. You're in. I see it now. Wait, I thought we were looking at the intersection of two arrays.
Wait, am I looking at the wrong one?
Yeah.
Okay.
Yeah,
intersection
so
of two arrays. Oh god. Okay, got it. I see. Okay, so n by n runtime. Good. Okay, yeah. Yeah, 5 you can reduce it. Yeah, so you fine, sure, whatever. This one's okay. Add in small one. Equal value. You don't have the advanced test. Okay, whatever. More optimal. Binary search. Okay, fine. Fine. Testing. List. Okay, empty lists. Yes. Okay, this one is good. Simple. I think this one is a little bit complicated because I get that you're trying to understand the empty array, but now you need to come up with what's the next simple example here that you could have come up with.
Okay, so if I have the empty array,
you're missing a very simple example that you could have used. I mean,
is it where the list?
You could just had it where there were two lists where they're both one.
Okay,
I get you're trying to do that here. I get what you're trying to do here, right? It's a little complex for my taste, but it's fine. And then you would also try swapping it for list 1, list 2. But I think overall this test case is fine. I think the test case that you've done is like if you argue from symmetry, then you're fine.
I was also trying to test skipping the duplicates.
Okay.
Because that's like a array gotcha for me.
Yes.
When you're iterating over this kind of stuff.
Okay. Good. So you recognize you're prone to the duplicate issues. Like, okay, that's fine. I do want to be careful. I think your testing is fine, but it's really important what properties you're calling out in each one of the tests. Which one are you? What scenarios are you testing and why? Because otherwise, you can confuse the interviewer. And it's like, wait, what exactly is this testing? But if you call out, hey, I want to test the case where we iterate over one element, right? Or elements over and over and over again. So this is fine. I get it. But then you also combine it with the, hey, let's also test with where we advance one pointer ahead multiple times before we advance the second pointer. So you're kind of combining two ideas in one. I don't mind it for the sake of efficiency, but but you can throw off people if they're not paying attention. And most of the time, interviewers not paying attention. So you really need to be explicit about calling out what properties you want to test. Other than that, I think your testing is fine. It seems pretty complete. I think it's a lot better. And so how long did it take for you to do this problem? 30 minutes?
Let me see. Let me see in the diary. I have it there.
Yeah, 30 minutes.
Yeah, 30 minutes.
Yeah, it's about right. I think that you just kind of went overboard with the naive solutions. I think you definitely could have sped that up faster. It's very clear to me you knew what to do, and the first 15 minutes was just boring bookkeeping bullshit for you. And again, it's important to be able to do it, but don't torture yourself into doing it if it's very obvious that. Remember, at any point, I should be able to ask you to do that boring bookkeeping bullshit. And I'm only making you do this as a exercise, but eventually you will be so sick of it, just like, fuck this, I'm just going to go straight for it, you know? So it's very important to balance that.
Okay.
That's fine. How you know all testing is covered? Yes, cover all paths, separate tests for B search. Yeah, that's fine. You were able to run through every single code and all the code paths were covered. I have no problem with that argument.
Yeah, and I did the separate testing for binary search as well.
Good. Okay, I like what I saw. Now, I want you to show me something that you think is like one of your weakest ones that you did. But yeah, that if you can do every problem like that, that's a very good thing.
Okay, sounds good. Sounds good. Well, the one that I didn't get at all, like I was just stuck in the example phase, was the one that I talked to you about earlier
Okay.
about the disjoint intervals.
Uh,
Um,
which row is this?
that's the very first page.
Okay, very first page.
Yeah, this problem, man, I didn't even get to my idea or brute force because I was just so confused with this example. So I don't know if this is a good one to talk about this, or should I say another one? Because I didn't even get to the testing part for this one because that's how stuck I was on this.
Got it. Okay, let's take a look at this. So the point I wanted to hit was the example, but okay. So the first one in your practice sheet, let's take or problem log. Okay. Oh, you have 118 pages. Damn. Okay. Compute the union of intervals. Okay. So is this a EPI problem?
Yeah, EPI. Yeah, no, 1 second. In Python is 13.8 in the Python book.
Okay, let me
It's
see.
a compute the union of intervals.
Got it. Okay, I see a Quora question actually. That'll probably tell me the. Wait, what? Fuck. I need the fucking text. God damn it. Actually, hold. Fucking hell.
Yeah, for this one, let me know and I can send you the image if you helps. You can find
Oh
it.
wait, I actually found the Python version. Sweet.
Oh,
So
nice,
I get to be right next to you on that. Oh wait, this is C++ version. Oh crap. Fuck. All right. Small visceral hatred for C++, but I respect it. All right, let's see. So union of intervals. The hell? It can't find it. Does it not have it in C++?
Oh, you may have the sample.
No, it's all 5 to 30 pages here.
Oh.
So
Okay.
what chapter is it under? It's under sorting, binary search tree?
It's under sorting, yeah.
Okay, under sorting. Let me see. Binary search tree. Or, okay, no, sorting.
The union.
A compute. Oh, I see. 14.1. Got it. Okay, I got it. 231. Got it. Okay, cool. A natural implementation. Yeah, let me bust it open here. So write a program which takes an input two sorted arrays and returns a new array containing elements that are present in both of the input arrays. Okay. The input arrays may have duplicate entries, but the returned array should be free of duplicates. So the input is 2, 3, 5, 5, 6, and then 5, 5, 6, 8, 8, 9.
Wait, I think you got the wrong one.
What?
Because here it says design an algorithm that takes as input a set of intervals.
Compute the union. Oh, I'm compute the union of. Fuck. Okay, I'm merge two sorted arrays. Fuck. Hold up. Yeah, I screwed up. I'm reading the wrong problem. So compute the union of intervals. Okay, got it. 240. In this, okay, I see. So they're giving you a bunch of. Oh, I see. That takes a design an algorithm that takes as input a set of intervals and outputs their union, expressed as a bunch of disjoint sets. So this example is actually quite clear, actually. I think, personally, it's like, hey, you have all these different intervals. Reduce them one other way to rephrase this is you have a bunch of intervals on a timeline. Reduce them to the minimum number of reduce them to the intervals that can cover every other interval without covering extra space. That's one way to read the problem, I think.
Basically, merge intervals, right?
Correct.
Merge intervals from.
Intervals with the intention that you can reduce it to as few intervals as possible that does not cover extra empty space. Yeah.
Okay.
So in other words, go ahead.
So I had a quick question. You see point 7 there? It has the open circle and the closed circle, right?
Correct.
So in Ceph math, that's not actually a 7. It's like 6.999, right?
Yes.
And then 7 is actually 7, including 7, etc. So the thing I didn't understand is like, how did they make that jump from the open circle to the closed circle, and how is that considered a 1? Since the first interval 5 to 7, that does not include 7. So
no, it does include it. So I think you have a misunderstanding of the math. So in set theory, right? If you have that open interval, you get 6.9999999 infinitely close to 7, right?
Oh shit. Okay.
And then you have 7 after that.
Okay. Yeah. So okay. So I wrote that in this entry here. That's probably like a gap in my knowledge, right, of math, of this type of math, because I haven't seen it in a while. So that completely threw me off. Like, and also I couldn't think of an example. I couldn't think of like a case here in this example where there's two white circles and what would happen, right?
Okay, I see. Okay, let's do something interesting. Why don't we do this? Why don't we make this the actual interview problem then? Since we need to do a problem together, why don't I make this the actual interview problem? This seems like a good one. So let's go to the let's go to your problem sheet, and then let's actually do this problem. I think that now we've talked a lot. I think that as long as you're doing the right things, I think you're on the right path. So all that's left is just really compound and just keep doing it. So there's not a whole lot of mistakes I really need to harp on you for. In fact, our sessions can be much shorter now because it's basically comes down to fix this mistake, and just keep going. So let's see. Okay, so C, problem sheet. Are you there?
Yep, I'm here.
Okay, cool. All right. So I don't have a fancy timer on me, but I'm just gonna go by the clock here. So give me a second. Okay, I'll at least take notes. And then here, let me get the timer out.
Okay.
Okay, I should have a timer. God damn it.
So for this one, you just want me to read it off the book?
Yeah, read it off the book, and then let's actually, but don't look at the answer. You know, let's give it a fair shake.
Yeah. Okay.
Screw it. Fuck it. I'm just gonna fucking write the time. I'll write what my current time is right now. 40, and let's go.
Okay, so shit. Okay. So this is 0 to 3, right? All right. This is probably gonna take me a while. Okay, so that is one interval, right?
Okay.
So let me write the first one at least to get this problem started.
Sure.
And then it's
I think one other thing I can do is I can actually just screenshot it for you.
Okay. That works.
Okay, so here, let me do that. There you go.
Okay, awesome. Okay, so design an algorithm that takes an input of set intervals and outputs their union expressed as a set of disjoint intervals. Okay, so so based on our example here, looking at 0 and 4, essentially what this boils down is merging intervals, right? So if I look at the first entry 0, the first interval, because we want to process this from the left to the right. Then you go all the way to the right. So this is just me thinking out loud. 1, 1 it lands in between the 0, 3 interval, so we can ignore that one. And then I see 2, 4. So this gets extended. This interval grows from 3 to 4 because it takes there's an overlap, and then it grows it to what is the max end on both. Okay, so this. Okay, so we want to merge intervals. We want to merge intervals if they overlap. Okay, so we want to merge intervals if they overlap. Okay, so there's a start and then there's the end point, right? These can be closed or open. So I'm looking at the example. If there's if you have a point 0, if you have a closed and open, the last result is going to be closed.
Okay.
So how would I do this in a very simple manner without thinking of optimizations? I understand what the ask is, right? Essentially, you're merging interval, right? Because I'm looking from 0. I'm looking at 0 to 3, right? And then there's other intervals that overlap it.
Sure.
So then it looks like it's getting extended, right?
Okay.
So then looking at 511, the same thing happens, right? There's an overlap here where the 7 is. So then that interval grows. And then in the 8, that interval grows as well. 9 to 11, that overlaps as well.
Sure.
So that gets added. Okay, so this is merging intervals. Merging intervals. What is the most naive way I can do this? Okay, so the most naive way to do this that I can think of. Okay, so the most naive way is if I start with one interval, right? Why don't I look at all the intervals it overlaps, right?
Sure.
So for example, 0 to 3, I see that it overlaps with 1, 1, also 2 to 4, and also 3 to 4.
Okay.
So why don't I okay, so these aren't sorted at all. I would have to iterate the whole array. So my first naive way to think of this is we have the intervals, right? Intervals. And then we have our output, right? Output result output.
Okay.
So grab an interval from intervals. What you do is find all overlapping intervals.
How would you find all overlapping intervals?
I would have to iterate the entire interval array.
Okay.
By iterating entire interval array.
And then doing what?
And then checking if overlap happens.
Okay.
For that logic, I have to see. So, for example, I have A to B, then it's C to F, right? So for the, I would, do you want me to write this down or do you just
No,
want me
I
to?
don't need you to write this down. Treat it like an actual interview. Pretend I'm here. It's like, okay, I know you're trying to iterate through the entire array, but how are you going to compare the intervals that overlap? You just said you're going to iterate through the array and waved your hands.
Yeah, so I would iterate the array, and I would check if the current interval that I'm iterating, if it overlaps with the current interval that I took out of this array.
Oh, I see. So you're doing basically two loops.
Correct.
Yeah, I would say do that. Just declare that because what you just said was fucking hand wavy as fuck, and it doesn't make sense to me. But you said two loops where you look at one interval and then compare it to every other interval, and iterate through the array doing that. That's fine. I get it. It's because when you say I'm gonna check if they overlap, then how are you gonna do that? That's the next logical question. But if you just said two loops, it instantly answers itself. So, yeah.
Okay, yeah, I guess that draws into the question of like the logic and all that, right?
Well, you already know. The thing is that any idiot can write two loops, and we understand what you're trying to do here. So, but then the question now is like, okay, you're comparing the overlaps, so then what happens?
Okay, so I would grab all the elements, not the elements, grab all the intervals that overlap, then merge them all together.
Okay.
And write it to your output list.
Okay.
Remove those intervals that overlapped from intervals.
Okay.
And at the end, sort the output list by start time.
Okay.
I don't know if that's a requirement in this problem, but
let's just say it's not.
Okay. So yeah.
Okay.
That's just like a nice to have, right? If you want to get it in chronological order. Okay.
Yeah.
So this is really slow. It's gonna run in, and then you look in at the other loops. It's gonna run at n times n time, right? Right.
Yeah. Okay. That's
n squared. Fair. Yeah. So yeah, this is inefficient. There's got to be a faster way to do this. So okay. So now that I stated my naive solution, I want to do something more optimized here.
Okay.
So looking at this problem, okay. So now what I'm looking at is like how it makes most sense to approach this problem. Like obviously you want to sort this problem by start time.
What does sorting get you? Why would you? Every action you take needs to yield a result, right? Or make it one step closer to an optimal result. Why would that get you there?
Okay, so sorting. So why I want to sort is because looking at the first example, right? You want to start at the beginning, and then this gives you an easy way to grab the next elements and check if there's an overlap. So for example, I look at 0, 3. Then on my next element, the 0, 3, I will add this to an output list. And then 1, 1, I can quickly check if there's an overlap. So for example, by comparing the end time of the previous entry that I added to my upper array,
okay,
if that is overlapping with the start time,
okay,
then that tells me that that there's a overlap.
Sure. Okay, that's fine. That's fine. I get what you're trying to do. You sort and then you build up your interval essentially, right? Okay, so then how do you know? And so your two options are what happens when the interval overlaps? What happens when the interval doesn't overlap? What happens?
Okay. So when the interval overlaps, you have to set the when the interval overlaps. So for example, in 0 and 3 and 2 and 4, let's just say those are the only two values we have. You see that there's an overlap. So what you previously added, it has a start and an end time. So that new end time is going to get updated to the max of 0 to 3
Okay.
or 2 to 4.
Okay.
Mhm.
That's fine. So that's what happens when it overlaps. All right.
Okay. Uh-huh.
And
It oh sorry, and if it does not overlap, so let's say we only have 0 to 3, and then we have 5 to 7, right? If there's no overlap, you just add that element to your output array. This is pretending we only have 0 to 3 and 5 to 7. Okay.
Okay, that sounds reasonable. Okay, I think you have the idea down. So, yeah.
Overlap. Okay. Okay. So let me see. Okay. So you sort the values, and then if you overlap, if overlap, else. What would you do here? If overlap, set. Okay. Okay. So I'll sort by start time. Sort by start time. If there's an overlap, so first I have to add the first entry. Add first entry to your result list, and then traverse the rest of the elements, excluding first element. Okay, so not elements, intervals. Okay, so if interval overlap, set result list latest entry to latest entry. Okay, so set result list latest entry. This is the end variable, right? And
Okay.
to max. Shit. Okay, so yeah, so okay, so set result list to the latest entry and to max output list dot end or current interval dot end. Otherwise, you just output to result list the interval. Okay, so this is like then you return output list at the end, right?
Okay.
So this idea, if I quickly test it, just by looking at the example, so let me see. So I have 0 to 3, and then I have 2 to 4, 2 to 4, 2 to 4, 2 to 4, right? First, it's going to add 0 to 3 to my list. It's going to be sorted by start time. It adds a first entry. Then you traverse the rest of the intervals by excluding the first element. So now this is this is my
Okay. 0, 3, 2, 4.
my-
Sure.
and then this is my current, which is 2 to 4. I see that there's an overlap.
Okay.
I see that there's an overlap. So what I have to do is set result list latest entry the end to max output list end and current interval end. So what's going to happen here is this is going to get updated to 4. Now I also want to test the interval that does not overlap, so we can check that other branch. Let's say it's 2 to 100, 200. Okay, so then current becomes 92 to 100. There is no overlap, so that just gets added to your result list, which is 92 to 100.
Okay.
Okay. So I have this down. However, there's sort of like this problem. You have to make sure when to merge these intervals, right? So we talked about earlier. There's if there's an open and closed, that means that you can merge the interval, right?
Well, let's not say you can merge it. Just say that you get infinitely close to that number. And so, yeah, you're right. You're calling out that you need some kind of validation check logic for overlaps. Fine.
Correct. So by that statement, is it okay to say in the example 5 to 7, 7 to 8, there's an open and closed. This is going to become 5 to 8, right? Because it has the open and closed.
Sure. But the question
Okay.
now is, how is this going to be represented?
Mhm.
So you want to think about that.
Okay,
How would you
okay.
represent it, and what kind of checking logic would you want? What does the checking logic approximately look like? I mean, I get what you're saying, but you're talking a lot, and I think you should really write these things down.
Okay, okay. Okay. So, oh shit. Okay, so this happens when okay, so that's the example that's throwing me off, right?
Okay.
Because you have to add extra validation checks.
Uh-huh.
So where am I? So there's an interval, right? There's an interval. Interval. Then it has a start and then it has an end, right?
Sure.
I have to represent somehow that this is going to be open or closed, right?
Mhm.
Open or closed. Okay, so okay. Okay, so if I have a class that has the interval start and end, if I have a class that has an interval start and end, oh, okay, this is okay. So I have okay, so I have the interval start and end, but there's got to be somehow to represent whether this is open or closed.
Okay. So how would you
Open.
represent this interval in order to reflect that?
Okay, so I'm thinking of the data structure to use here. It's straightforward to use the interval start and end.
But you obviously can't encode the open or closed. So you need to add more to it, right? Because you're forced to, right? So what are you gonna do?
Okay. So, oh man. Let me see. I have my interval start and end. Then I have the. Okay, so shit. I have my interval. I have to add more to this.
Mm-hmm. So how would you do that?
Okay. What if I have something that represents the number, right? The number, and it's gonna say closed or open, right? Yeah, this would have to be some other.
Okay, here's a hint.
Entry.
Why not just encode it as a string and read the string?
Okay.
You read a string literal, and then you just read the string and then get the values of open, close, start, end from that.
Okay, that makes sense. So essentially what it becomes is like an interval, and then it has the string, right? This is the number, and then it has something like a closed or open, right? Okay, so yeah. So this would be the start, right? And this would be the end. Is that like what you hinted towards?
Well, why not literally write like 8 and then 9? Why not literally write this? That didn't seem very fucking hard, right?
Mhm.
So let's put a pause here. Why did this idea not come to you? What's the idea is how do I encode open close interval and the number?
Mhm.
Why did this idea not come to you? Let's ask that.
This is because string parsing. I put this in like the hard category, as opposed to doing like a class, right? Like a class that would represent your interval start, and then it has the start and the end, and then inside of those it would have whether it's open or closed.
Sure. I mean,
So yeah,
I get what you're doing. I get why you do it, and you should have just done. You should have just went straight for that. It says, okay, let's have a class, and then I would have countered. Well, do you really need all that memory? Is that the most memory efficient way to do it?
Oh, I see.
And then you would have been okay, parsing a string. Yeah. So technically, string parsing is hard. You're right, but all roads lead to. I would argue that in this case, all roads lead to Rome, and this is relatively simple to parse, right? All you're doing is read the first. But yeah, let's go with the class for now, because I understand what your concern is. But believe me, in an actual interview, they would actually just make you fucking do this.
Okay.
I think for now we could just do a class, and then you could say, hey, this string parsing is too hard. Just go. It's up to you to make that declaration. So you kind of meandered and just rambled for the fucking past 3-5 minutes and pissed me off. So, but you need to fucking go say, hey, I want a class that represents this. I know there's a easier way to do this, but let's start with something naive. Very simple.
Okay.
So you really need to be in the driver's seat, and you didn't do that. So go ahead, go with the class for now.
Okay. Okay, so if we go with the class, this is going to be the interval class, right? And then it's going to have let's say it's it has the start and then it has the end value, right?
Okay.
This is going to be equal to let's call it entry. Entry that has the number, and then it has closed open or closed, right?
Okay, fine.
Let's say it open. This is a Boolean.
Sure.
Okay, so going back to the so this merge list it works, right, for without this extra logic of the start and open, right? So I will sort the intervals by now that I have this, sort by start time, right? You sort by start time, and then if I look, I'm looking at the example now. I have to be careful of like these use cases, right? Like it's easy to merge the intervals, right? But what constitutes a merge, right? We said, oh yeah, let me write this shit down. Okay. Constitutes a merge. If both points are equal and one is open, if one is closed. Okay, so if both points are equal and one is open, you can merge the intervals. So if both points are equal, so I'm looking at the cases now. So if both points are equal and one is open, you can merge the intervals. If both points are equal and both are closed, if both are closed, okay, yeah. So that's what I didn't see in this example. if both are closed, that means that you can extend the interval, right? Um,
if both are what?
if both are equal and both are close, they have close points. That means you can merge the intervals.
Yeah.
You can merge. Okay, so now for my other case, if both points are equal and both are open, that's where I don't get here.
Okay.
So because there's no clear example here.
Okay.
Where,
Fine. So I'm going to give this one to you because if they're both open, then you have one side that's 6.999999, and the other one that's 7.0000001 or right. So they'll never touch. So
okay.
I'll give that one to you. Do not merge them.
Okay. Okay. Cool. So now, okay. So I have what constitutes a merge. Now what I have to see is okay, so what constitutes a merge? I talked about all the three cases that can happen. I don't think there's another case that can happen, right? Because you only have two, open and closed.
Sure, but then you also have like what happens if 1 point is actually I think you got this. So why don't you? I think you understand the idea. I think you thought of it pretty well, and then you understand the merge thing. So why don't you write the code for it?
Okay, so I have of intervals. I have the intervals. And this is assuming it's in the format I talked about earlier. Sure. Is that fine, or do you want me to
Sure, let's just say that you have an array of those interval classes or some shit, yeah.
Okay, so then I'm going to sort by start time. Intervals.sort. Key equals, this is to sort by the start time. Start time is x dot. Okay, looking back at the class, it's gonna be dot interval dot start dot num. Okay, dot interval. So I have my x is the interval. So then you have to go into the start, and then you have to go. Let me see. Into the num, right? Because you want to sort it by start time. So this is going to sort it by the start time. So then add first entry to the result list. Okay, so taking care of the case of if non-intervals, empty list, right? So then you have to add the first value in the intervals. And then I'm going to loop the rest of the intervals for interval in intervals. Okay, so going back to my idea pseudocode. Okay, so you add the first entry, then you're going to traverse the rest of the intervals, excluding the first element. If overlap, then you do, I'm going to write down this idea here because there's too much back and forth here.
Okay.
Yeah, so, okay, so if result list, okay, if result list, you look at the last entry that we added, it's always going to be the case that there's an element here, dot end. Okay, so I have to look at the new start time interval dot start dot num. Okay, so now 0 to 3, what's going to constitute a overlap? If the new interval, the start time is less than and equal to the last end time.
Okay.
That's gonna tell me to update. There's I have to update the latest entry. So result list -1 dot end dot num equals max of both of these. Okay.
Okay.
Else there's no overlap, so just add it to the result list. Okay. So I did the basic idea here. Now let's take care of the idea where we talked about up here.
Mm-hmm.
Let me see. So okay, so we talked about the 3 cases that can happen, right? So what constitutes a merge? Okay, so okay, so this. Okay, so if both points are equal and one is open, you can merge the intervals.
Okay.
So, okay, so if both points are equal, okay, so here I'm just doing the case where it overlaps, right? I'm not doing the explicit check where it's actually equal to this interval. So for this, I'm looking at my branches here. If both points are equal, so it looks like in all these cases, in all these checks, I have to check if both of these points are equal.
Mm-hmm.
So okay, so if and okay, so that tells me both points are equal, and shit, okay. And I have to check if one of them is open.
Okay.
And this is so what did I say? I defined it to be, so I'm looking at what I defined it to be. I have num and open, okay? So I can say if both numbers are equal and one of them is open, result to dot end dot open, or okay, so this is the interval start, the num, and I'm checking whether one of them is open or not. Okay, no. This has to be the interval, right? Okay, so if result list is equal, god damn it. Yeah, okay, so I'm checking here that both the end and the start are equal. So by doing that, I do, if result is end.num equals interval start.num, and this is where I have to check whether they're open or one of them is open. Okay, so I check that the both numbers are equal, and I check if one of them is open. interval dot start dot open. Okay, so then I can merge if this is the case, right? Okay, so I'm looking at the other cases, right? This is not the only case I want to handle, because looking at those 3 branch statements I wrote here below, okay, so it looks like here below, this is taken care of, and this one as well, right? Because I have an or statement. If both points are equal and both are closed, I can merge the intervals. So then, if both points are
Okay,
equal,
I'm gonna stop you because holy shit, this is really pissing me off listening to this. Do you know how long you basically spent on this?
No.
7 minutes.
Oh,
You
shit.
spent 7 minutes trying to write this fucking statement. Do you know like how bad that looks? Like
Yeah, it's
from a
pretty
coding's
bad.
perspective, how do you not know how to write this statement? That's my question. Let's start there. What are you blocked on? Let's stop because I'm like you're basically fine up until this one point.
Yeah,
And
yeah.
I'm trying,
Okay,
and
so
I really need to figure out what the hell's going on here.
okay, so what I fucked up here is the result list -1.n.num. I should have just set that to a variable up at the very top, so
Sure.
it can be easier to think about. Because
Yes.
as I was writing this just slowed me down, and I have to keep going back to the idea or the pseudocode
Yeah.
to see what exactly that does.
That
Yeah.
that could help you, but I think it's something it's. I'm trying to figure. I'm really trying to troubleshoot what the hell's going on here. Like, yeah, that can help you. Let's say you did the variables. Then what? What else?
So once I got that, then this would be much faster to code up, because there was a lot of back and forth between the code and the idea here.
Yeah. Okay.
Yeah, yeah.
That could have helped, but like fundamentally, all you're really testing for is whether or not the numbers are equal, and one of the flags is true. That's it. And if you just broke it down, if the points are equal, you just copy paste whatever the hell you had or assigned to a variable or whatever, and add one of the is open, which is just like interval dot last interval dot open and or does not equal interval is open for the other one. That's it, right? It's an XOR check. So this is where I cannot help you in this situation because the code is so fucking simple. The idea is so simple.
Yeah, yeah.
Why you can't code it, I cannot help you there. This is like, I guarantee you, if I gave this fucking problem, at this point, like I laid out what to write, and I gave it to a fucking college student who barely knew how to code, they could write it. So this is the part I cannot help you on. So I think this one's gonna be up to you to try and figure out.
Okay,
I'm stopping the interview here because there's no point in me trying in you hammering it away. So
Yeah,
this is just for the sake of time and for our sanities, I'm going to stop it here. But other than that, everything up to this point was fine.
Okay,
Like, you did ramble a little bit at times. I really had to help you with focusing in on like what the intervals, like the n interval meant. But really, this is a really good problem that you look back on and say, what the fuck is wrong?
Okay.
Yeah.
Okay, so for my homework, what I'm gonna do is like I'm gonna minimize going back to the idea in code and write better variable names here, because yeah, that whole that's a big bump. Putting the 2 classes together, that made it more complicated as well. So yeah, that required a lot of going back and forth to do. So I gotta be more mindful to choose classes or strings that are going to be easy
That's
to remember.
not most of the point. The point I want you to really take away from today is how can I make this idea as simple as possible and no more simpler. In fact, for this, I would have said, okay, so there's this huge if statement for like you can merge or you can't merge intervals. Ultimately, you're just deciding a flag. So why not just fucking put this in a fucking function? That's it. That's like what I'm thinking. And then, of course, you can do the variable names and whatnot. But really, you need to figure. I cannot, like I said, I cannot help you here. Why you can't code a simple if statement? So, that's really what it boils down to. How do you code an if statement? And okay, enough harping on that. You know what your homework is, but basically just
Yeah,
keep
yeah,
hammering at problems. You do like I think you do well when I explicitly tell you what to do. But
yeah,
when it
yeah.
comes to
Okay.
like trying to analyze your own mistakes, you basically fizzle out and can't do and don't know how to do it.
Mhm.
And so I'll see if I can figure out a way to make this simple for you, but honestly, it's as simple as it can get. If
Okay,
it can get
okay.
any simpler, I would have told you, or maybe someone in the crowd can figure it out. But I can't fucking figure it out. And so I think once you come up with an answer for this, really think about what it takes to get there faster.
Mhm.
Uh, Other than that, like yeah, just keep doing with the testing thing. I'm very happy with the fact that you actually were able to think about the tests, but I think it could be a little bit more complete. So I'm not. Yeah, this is the one sore point I really have a fucking
Okay,
time
okay,
on,
okay.
and I don't know, man. So it's just basically do more problems and really, like I said, zero in on your mistakes and never make them again. You really need to basically, like, fucking bully yourself into it.
Yeah, yeah. So when I was doing this, like what you talked about before, like there's like this gut instinct, right? Like this long variable name is gonna bite me in the ass later.
Yes.
And that's what happened, right? So as I was doing this, I was like, oh shit, the this is what's gonna happen. So yeah,
You copied
yeah,
the variable name like 3 times. That should have instantly screamed, "Wait, this should be a variable," because you still have some further refactoring to do.
yeah, exactly.
And also, like anytime you have like this level of indirection, the last result list .n.num, you keep reaching in. That should be like, oh, I need a variable. So yeah, that's it. That's basically these are like things that you develop as when you actually code professionally, though. That's
Yeah,
the
yeah.
strange part. So this tells me that you like when I look at this as an interviewer, right? I'm seeing the way they code, right? And the fact that you did this kind of tells me that you tend to copy paste code a lot in your own actual job. Am I hitting the nail on the head here?
Um, I think I would say it's more like the time constraint, right? But that I should fix this, right?
It's not an even time constraint. It's like instantly. If you had fixed, like,
Mhm,
okay, if you break down the timestamps, you basically started, like, let's say, like, we started at 45, right?
mhm.
And then if you look at the timestamp, you basically start coding at 10, which is like, what? That's less than, is that 15 minutes? No, that's 25 minutes. That's fine. 25 minutes and then 10 minutes to code it.
Mhm, mhm.
That's perfectly normal. I think you were on track. Of course, like part of it is you rambling, and if you cut that out and you just start
Yeah, yeah,
like looking for magic bullets in the classes, you could easily cut this down to 20. So it's not the
yeah.
time constraint at all that is looking at it when I look at this. It's
Okay.
literally you don't know how to do an XOR check, and you can't catch yourself copy pasting code. It's not time constraint at
Mhm.
all. I guarantee you, any interviewer would be happy to give you an extra 2 minutes if you can make the code clean and sane.
Okay.
And would it take you 2 minutes to fucking write the variable name?
No.
Yeah.
It'd
So
be much
yeah,
faster.
when you call it time constraint, that's where like recording yourself and looking at the time stamps is gonna help you.
Okay, okay, okay.
So I don't. The time constraint's completely in your fucking head. Don't
Mhm.
worry about the fucking time. The interviewer will
Mhm.
call you for time
Okay.
because when you start worrying about time, you get sloppy, right? And you
Yeah,
start cutting corners.
exactly.
You start
Yeah.
cutting corners. You're basically driving without insurance. You're driving without a seatbelt. But, like you're driving down the fucking highway at 100 miles an hour, and you don't want to put on a seatbelt because you want to save an extra second.
Mhm, mhm.
That seems really stupid to me, but
Yeah, yeah, yeah.
all right. Any final questions?
Uh, no, no, I'll just keep hammering at these problems and thoroughly analyze these timestamps and
Yeah.
yeah, basically go from idea to code much quicker. So that
Idea from
definitely
code
needs
much
more work.
quicker. I don't mind you being this complete, but really, you need everything you say that's coming out of your mouth needs to mean something. And I caught you a lot
Yeah,
of times rambling. And then this
and also
final thing
stop
of making
rambling.
sure that you can glue the idea to your code. Other than that,
Okay,
there wasn't really any other problem. So,
okay, okay,
okay, with that I'll let you go then.
okay, okay. Awesome. Thanks, man.
All right, talk to you later.
All right, see ya.
Any final questions from the crowd? Going once, going twice. I'll give it a minute. All right, I guess I'll stop the stream. Thank you all for watching me. We'll be back here Thursday, 8 p.m. Pacific Standard Time, unless I let you guys know. Work has been pretty hectic, so we'll see if we get the stream. So, Yeah, with that, follow me on my Discord. I will post the announcement there. Socials are in the link in the description down below. And if you guys want coaching, you can book me for interview coaching at eachhandtech.com. Other than that, have a nice night, and I'll see y'all later.